All right, welcome to session 2 of our Survey of Contemporary Mathematics class. This week we're going to take a look at chapters 4 and 5. We're going to be looking and reviewing on ratios, rates. We'll also begin to look at percentages in chapter 5. So lots of review. Hopefully some of this will come back to your memory from things you learned in school. But please reach out this week if you've got some questions and let me help you along the way so you don't get so frustrated. So starting off, our first definition is a ratio. This is a comparison of two quantities that have the same unit. In this first example, we want to write the comparison as a ratio in simplest form using a fraction, a colon, and the word to. So whenever we write a ratio, it's going to be in a fraction form, okay? We want it in the simplest form possible. So if we're able to reduce that fraction, we will do that, okay? If it were improper, you would keep a ratio as an improper fraction. We do not turn ratios into mixed numbers, so we would keep those in fraction form. Unless it asks for another method, which is, there's 3 we're going to review: fraction, colon, and using this word to. So let me give an example here. So I have 6 pounds to 8 pounds. So as a fraction, I would set that up just in the order that is given to me. All right, now the thing about ratios, because we're using the same unit, these cancel each other out. So I really just have to refer to that fraction. But I can reduce this because 6 and 8 are both even, so they're divisible by 2. That would equal 3/4. So this is my fraction answer. Using a colon, we could write that as 3 to 4. Okay, so that's a colon answer. And with the word to, you just simply write 3 to 4. No matter what method you're given, it's still read this way: 3 to 4. 3 to 4, 3 to 4. Okay, so fraction, colon, and with the word to. Now, as far as giving your answer for a ratio this week, I do not care what method you give it in unless a problem specifically asks for something. And there are several that ask for fraction or colon or vice versa, whatever, I don't know. But just read those directions, because you might have the right answer, but if you don't give it in the form that it's asking for, then you'll have points deducted for that. So just really be careful and pay attention to those details. Okay, next 2 definitions. A rate is a comparison of 2 quantities that have different units. So very similar to a ratio, a rate is just a type of ratio. And a unit rate is a rate that has a denominator of 1. So unit rate is like driving 60 miles per hour. That's how we would describe a unit rate. How much does it cost per ounce, or how long is it per hour, whatever the case may be, but that denominator is 1. So in example 2, it says write each phrase as a rate in simplest form. Kind of like the ratio, I'm going to set it up as a fraction, simplify it. I'll look at the other methods with you. But it's 2 different units of measure. So we've got 30 ounces, and you can abbreviate, to 24 glasses. Okay, so I can't cancel out the labels this time like I did before because they're different, but I can reduce. Both the numerator and the denominator are divisible by 6. So this would be 5 ounces to 4 glasses. Okay, and I could write it like that. I don't mind if you abbreviate, but be real careful with the ounces. You don't want that O to accidentally look like a 0 and you type that in as 50. So just be careful that you can read your own handwriting when you're transferring answers into the Excel document. Okay, so watch your labels and have those as necessary. Do reduce when it asks you to do so. Example 3 says write each phrase as a unit rate. So this is when we want to know how much is it cost, or how much are you earning per week. I have $3,900 earned in 4 weeks. So how much is earned in 1 week? So it's like per week. So I'm just going to take $3,900 and divide that by 4. And I can just type that directly into my calculator. Here, 3,900 divided by 4. And that's going to give me $975. Don't forget your label. I can write that, this way, okay, or I don't mind you even doing it like this. Okay. But either way, I'm indicating that amount earned per 1 week, because that 1 is understood to be there whether we write that or not. Okay, so that's just some review of ratio, rates, and unit rate. Really main thing to watch for, and the biggest mistakes that I see students make is not reducing it completely or correctly, and not giving it in the form that it's asked. So just pay attention to that. All right, next definition is a proportion. The reason we need to know how to work with ratios, one of the big things for algebra is using those to solve a proportion. A proportion states that 2 ratios are equal to each other. So you can solve proportions by finding cross products. This obviously is not the only way to solve proportions. Sometimes there may be an easier way, but cross products always work. You're going to have some problems like example 4, where they give you 2 fractions, 2 ratios, and they're asking you whether these are proportional or not. So I've got a question mark there. Is this true or false? So I can use cross products to check whether 2 ratios are proportional. To do that, I'm going to multiply 4 times 20, that's 80. 8 times 10 is 80. If the cross products are equal, then the ratios form a proportion. And they do, so I'll simply say yes. You will probably have to justify that question on the apply. So are the 2 ratios proportional? Yes, they are. That's true. Why is that true? Because cross products are equal to each other. So let me do one more example like that. 7 times 12 is 84, but 8 times 11 is 88. See how these are not equal to each other? Cross products are not equal, so the ratios are not proportional. And that justification is because cross products are not equal to each other. Okay, so in example 5, using that process, we can solve a proportion. Notice here I've got 2 ratios that are equal to each other, but I'm missing one of those values. Okay, I've got to solve this proportion and find out what x is. You may be asked to round a certain way, so really be careful about that. I do deduct a point if you do not round correctly, so pay attention to those directions for each question. So, I could look at this. I know that 4 times 2 is 8. So I could ask myself, what would I multiply times 2 to get 6? And I could find the answer to that question. But I am going to work this out with cross products because not every problem can be worked that easily. So with cross products, I'll say 8 times x equals 6 times 4. And then this is a simple one-step equation. 8 times x. To solve, I'll divide by the number in front of the variable, and that tells me that x equals 3. Okay, so that's just using cross products to solve a proportion. So for this answer, x equals 3. Let's do one more of those. So to solve a proportion, we can find cross products. 8 times x must equal 9 times 12. That's 108. And I'll divide by the number in front of the variable. So 108 divided by 18, this equaled 6. I don't know, these 2 didn't even require rounding, but you may have to round on the test, so be careful that you pay attention to those things. Now, let me just talk about decimals. Let me just make up one while we're here. Okay, so remember, past the decimal, we go tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, and that goes on forever. Okay, so 2 is in the hundredth spot. If that was an answer and I needed to round to the nearest hundredths place, so 2 is in the hundredths place. That means I only want to show 2 numbers past the decimal, but I have to look at that 3rd decimal position to decide if this stays a 2 or if it becomes a 3. So this is what I tell my students at school. Looking at that number right past the 2, right past the hundredths place. If it's 5 or more, we'll bump up the score. 4 or less, let it rest. So this would round to 3.2, okay? 3 is 4 or less, so 2 stays a 2. Now let me just give another example. I'll do one similar to that. But let's say that was 5. Okay, so if I'm still rounding to the hundredths place, I only want to show 2 numbers past the decimal, but I have to look at that third number. 5 or more, right here, bump up the score. So then that would round to 3.13. For your decimal position, you know, whenever you get to that position, the hundredths, you don't need any other things after that position, okay? So if you're not really good at rounding or if you've forgotten how to do that, please look over, you know, some old videos or something to help review that. Okay. All right, let's look at some word problems. These word problems I'm actually getting from your textbook. If you want to look along in your textbook, you're welcome to do so. These come from page 197. So from that page, these are numbers 20, 23, and 30. So I just want to show you what numbers those are if you are looking in your textbook. So number 20 says the property tax on a $245,000 home is $4,900. At that same rate, okay, what is the property tax on a home valued at $320,000? Okay, so what I want you to notice as you read this, we're comparing two things, property tax and a home's value. Okay, we just see that repeated, property tax, home value, property tax, home value. When you set up a rate, it does not matter the way that you set it up to help you solve a proportion, okay? So what I'm saying is you've got to be consistent on the left side and the right side. So for me, I'm just going to take, because of what numbers were presented to me first, I have the home's value and then the tax on that home. So that's just how I'm going to set up my proportion. But I must be consistent with the other side of that equation. If you had set tax over value, then the right-hand side would have to also be tax over value. That's what I'm saying. Like, it doesn't matter which one's on top as long as you're consistent with the left and right-hand side. So the first home value is $245,000, and the tax on that home is $4,900. I don't even have to put the dollar signs because those would actually cancel out. So that equals a home valued at $320,000. Question is, what is the property tax? So that's the unknown, and we use a variable to represent that unknown. So I have a proportion. We can solve a proportion by cross multiplying, okay? So some big numbers, I could simplify this first, but I mean, we don't even have to do that. So I'm going to cross multiply. I'll show a few steps. $245,000 times X equals 320,000 times 4,900. So I'm going to multiply those, really big number in my calculator. I'm just copying that right down, multiply that, copy that down. We always divide by the number in front of the variable there. This is 245,000 times X. So I don't have a lot of space here, but I'm going to divide by that. One thing just to help quickly simplify this before I put it in my calculator. Notice how these numbers all end in 3 zeros. They both end in 3 zeros. I can cancel those 3 and cancel those 3. It's like dividing each number by 1,000. I could do that. Just simplifies this. So then I would only put this in my calculator to divide. Okay. So dividing that's going to tell me that X equals $6,400. So at that same rate means I'm setting up a proportion. You decide how you want to set it up. I've got value over tax equals value over tax. Fill those in consistently. Cross multiply to find that missing number. Okay. And the next example is going to be similar to that. A brick wall 40 feet in length contains 448 concrete blocks. At that same rate, okay, there we see that again, setting up a proportion. How many blocks would it take to build a wall that is 120 feet in length? So I've got length of a wall, bricks needed for that wall. Length of a wall, how many bricks are needed for that wall? Okay, so be consistent. You can't just take the numbers that come first. That's not how it works. You got to make sure that you're putting those in the right spot. So I've got length of a wall and how many blocks it takes for that wall. So each side got to be consistent with how I fill that in. So I have a 40-foot wall takes 448 concrete blocks. That would be equal to a 120-foot wall needing how many blocks? Okay, so set up the proportion. Labels don't really matter in this because I'm going to cross multiply and solve. This is what I'm looking for, so that'll be the label for this answer. So 40 times x equals 448 times 120. You can check in your calculator as I multiply this in mine. That's going to be 53,760. Divide by that number in front of the variable. So I get x equals 1,344 blocks. It should make sense to you that it's a longer wall, so it's going to take more blocks to cover that wall. Actually, if you're looking up here, it's 3 times longer, so 3 times 448 could have given you that answer as well. All right, one more word problem. A house had an original value of $160,000, but its value increased, and that value is now $240,000 over a period of 2 years. This time, I'm just finding the ratio. I'm given that ratio as a fraction in simplest form, okay, of the increase to the original value, okay. There is a problem on your apply very similar to this. I'm going to tell you, most people miss it because they're not really carefully understanding what this question is asking. I'm not setting up a ratio of the new price to the original value, but the increase in price to the original value. The house valued originally at $160,000. Now it is worth $240,000. So you have to ask yourself, how much did it go up? Because that's what I need to know for this first part of the ratio. So I can take $240,000 and subtract $160,000 from that and see that that increase in value is $80,000 more, okay? So here's how I'm setting up my proportion. The increase, it went up $80,000 to the original value, which was $160,000, okay? The only thing I needed to know this for was to help me figure out how much it went up. So be very careful. There's a question on chapter 4, apply, really similar to that. Follow this example. I can cross out an equal amount of zeros on top and bottom, okay? Really simplified that. It's like dividing them both by 10,000. That leaves 8 over 16. That will reduce again, both by 8, and I get 1/2, 1 to 2, okay? So it's a ratio, a fraction in simplest form. This told me how to set up that ratio. 2 over 1 is not the same answer. I'm not setting up original value to increase, but it was the increase in value to the original value. So how much did it go up to the original amount? Okay, so read that carefully. All right, moving into chapter 5. Chapter 5 starts with percentages. So here's a term you need to know. Percent means per 100 or parts of 100. And so we use the percent symbol anytime we talk about percents. So a percent is a way for us to represent a value. Percents, decimals, and fractions. Okay, so we have to learn how to convert from one of these forms to another. So in example 1, it says write the percent as a decimal and as a fraction. So I'm going to give 2 answers here, a decimal answer and a fraction answer. So we're given 72%, but we know that percent means per 100 or parts of 100. So I can drop the percent sign when I take that number and divide it by 100. Okay, that's my fraction form. Now I will need to reduce this, but that is how we go from a percentage to a fraction. Now while I'm in this part right here, I'm going to quickly take this to a decimal. If I read this fraction correctly, it's 72 hundredths. And so to write that in decimal form, that would be 0.72. Now I'm going to talk to you another way of how to convert that. Maybe that will be helpful, especially when we look at these with decimals. Let me kind of refocus that here. Dividing by 100. This was a question on last week's apply. Some missed it because they were giving me directions on how to multiply by 10, 20, 100, and 1,000. But the question asked, how do we mentally divide a decimal number by 100? And the answer is we take that decimal and we move that decimal point to the left, however many places there are zeros. Okay, so in this case, for percentages, we're always dividing by 100. It has 2 zeros. So a whole number has an understood decimal at the back of it. So I just have to move that decimal over 2 spaces, and that's how I can convert a percentage to a decimal. So 72 hundredths, that's my decimal answer. Now I'm going to take that 72 over 100 and reduce it. Both of these are even, so I can divide by 2. I can probably do more than that. I think 4 will go in. Yes, 4 will divide into 72 18 times. 4 will go into 100 25 times. And you just want to simplify that down as far as you can. Just start with common factors and work your way down until it's in simplest form. All right, here's another one. This one is a decimal. To turn a percentage into a fraction, you drop the percent label and divide it by 100. Okay? Dividing by 100 shifts that decimal over 2 spaces to the left. So that's 0.254. You can put a 0 in front. That's fine. That's the decimal, okay? If I'm reading this decimal correctly, because I don't ever want to leave a fraction with a decimal, that's just not proper. This is tenths, hundredths, thousandths. So that fraction is actually 254 thousandths. And I want to reduce that if I can. They're both even, so I can at least divide by 2. 254 divided by 2 is 127. 1,000 divided by 2 is 500. And I believe that's as far as we're going to be able to take that problem. I have a fraction and a decimal answer. Okay. This one was a little bit easier to take it into decimal form and then from there go into my fraction form. Let's do one more of those. This is 0.25%. It's not 25%. It is a decimal percentage. So I need to keep that decimal. When I drop that percent, I divide it by 100. Okay, so let me say this also, because I get this all the time. I'll have students that drop that percentage and just tell me that's the decimal answer. Those are never the same, okay? 72% is not 72. It's 0.72. That's the difference. We're dividing it by 100, so don't make that mistake. When I divide it by 100, I shift the decimal 2 spaces to the left. If there's nothing there to go around, you have to put zeros in those positions, okay? You can put a 0 in front. That doesn't matter, but these two really matter. So if I want to go now to a fraction, I've got tenths, hundredths, thousandths, 10,000ths. So that's 25 10,000ths, okay? I want to reduce 10,000 divided by 25 is 400. So 25 divided by 25 is 1. 10,000 is also divisible by 25, and that would give me 400. So reduce that down as far as you can. That's how we get a decimal and a fraction from a percent. right, so I want you to think about what we've just done. When I have a percent, I divide it by 100. I move the decimal 2 spaces to the left. What do you think I'm going to do when I want a percent? Okay, I'm going to need to do just the opposite. I have a decimal. Okay, so instead of dividing by 100, we're going to multiply by 100. Multiplying shifts my decimal 2 spots to the right. So 0.16, I don't know if you can see that very well in the video, 0.16 is the same as 16%. And that's all it asks me to do here is just write that as a percent. Okay, 1.012. If I want a percent, I have to multiply by 100. That shifts my decimal 2 spaces to the right. So that's 101.2. Don't forget to label your percent. That's a big deal. If it asks for a percent, make sure to give your answer as a percentage. But do not tag on that percent if the question wasn't asking for a percent. Okay, let me go back up here. When you have a percent, divide by 100. Shift your decimal 2 spaces to the left. When you want a percent, multiply by 100. Shift your decimal 2 spaces to the right. You may want to take a couple notes on that. And the way I worked these, okay, will be similar to how I worked these two fractions. Here I had a percent, so I divided by 100, reduced that fraction down. Here I have a fraction and I want a percent, so once again I'm going to multiply by 100 and simplify that. This would be 27 times 100 divided by 50. So I want to simplify that if I can. 2,700 divided by 50 is 54%. Okay. I have a fraction and I want a percent, so I'm going to multiply by 100. That would be the same. And remember, when you multiply a fraction times a whole number, just put that over 1, okay? You only multiply the top together and the bottom together. You're not multiplying 100 times the top and bottom. That's not how you do that. So that would be 500% divided by 8. Okay, now let me show you what I get in my calculator. Well, I mean, that one did divide evenly. I would accept that. Don't forget, you know, how to do long division if that was a repeating decimal and it might maybe ask for a mixed number. I'm not sure if you have any problems like that, but, you know, once again, you can do the math if you needed to give a mixed number. Of course, that one is easy to interpret. That's 62.5% or 62.5%. If it's repeating, I know we talked about this before, but you know what, let's say like that was 62.3 with a Repetin bar, because you know if that 3 just kept on going. In Excel, to show that that decimal repeats, we really should give several numbers and do the ellipsis if that is a repeating decimal. It's not really necessarily proper to do that with percentages, but I guess you know you could, or remember that 0.3 of the Repetin bar is the same as 1/3%, so that would be best. And you could get an answer like that by actually doing long division if a problem was specific about giving it in that form. I just totally made that one up. Okay, let me go over that rule one more time. When you have a percent, divide by 100, shift your decimal 2 spaces to the left. Okay, dividing by 100 gives you your fraction. Shifting your decimal 2 places to the left gives you your decimal. When you have a decimal or when you have a fraction and you want a percent, you multiply by 100. Shift your decimal 2 spaces to the right. Multiply the top by 100, divide it by the bottom. Okay, that's going to give you your percentage. Don't forget to label with a percent when it asks for a percent. Okay, a couple of things I want to remind you of in math. We'll see some problems that use words is and of quite a bit. And so when we're finding a percent of a number, or if you know a part and we're dealing with percents, you need to remember that is oftentimes means equal in math. So whenever we see is, we can replace that with an equal sign. Of typically means to multiply. So when you see of, you can replace it with a multiplication symbol. So I'm going to do a few of these. I've got several, but I may not work through them all. I've got 88% of 100 is what number? Okay, so I'm just going to rewrite this and replace it with these symbols like I just mentioned. So 8% of times 100 is what number? I don't know. That's my question. So I'm going to use a variable to represent that unknown. So ultimately in this problem, I'm multiplying 8% times 100. And my calculator doesn't even have a percent button. Maybe yours does. That would make this even more easy for you. But when we work with percentages, I really do not work with that percent. Like in the last problems, I've got to convert my percent to a fraction or a decimal. So I just know that percent means per 100, so I could use 8 over 100 and multiply that times 100 to find that. Or 8% is 800ths, which is the same as 0.08, and multiply that times 100, and that would help me find what W is. Either way would be easy here. In this case, those are simply going to cancel, and W equals 8. Or here, shift that decimal over 2 spaces, and W equals 8. So 2 different ways to work that same problem, but we get the same answer. Just depends on whether you like working with fractions or percents. We're going to be doing a lot of work with percentages in upcoming chapters, so really need to get a good grasp on this before we leave this week. Here's another one. 27% of, that means multiply, 40 is what number? So I'm multiplying 27% times 40. Remember, percent means per 100. That's the same as 27 over 100, or 0.27. I'm actually going to use the decimal, multiply that times 40, and that will equal my number. So in my calculator, I'm taking 0.27 times 40, and W equals 10.8. Okay, so know how to take a percentage, convert it to either a fraction or a decimal, and work through a problem like that. Let me do this one right here. What percent? Notice this question is asking for a percent answer. That's important that you realize that. So what percent, that's what I don't know, of 75 is 24. Okay, so 75 times something is 24. I'm going to solve for W. I could actually rewrite that as 75 times W equals 24. I'm going to divide by the number in front of the variable. Okay, I get a fraction. I'm going to take that fraction and change it to a decimal. So typing in my calculator 24 divided by 75, I get the decimal 0.32. But I'm not going to stop there because the question asks what percent. So I'm going to multiply that times 100 to shift that decimal over 2 spaces, and that would be the same as 32%. So be careful. If the question asks for a percent, make sure we give that percent. If not, you know, I'm just looking for a number or a decimal or a fraction, whatever it asks. I may come back and work a few more of those, but I'm going to move on to a few more word problems before we end up chapter 5. If you're watching this at a later time, our code word tonight is ratio. You can email me a brief summary of the video tonight and include the code word ratio for your extra credit. These additional questions come from page 227 in your textbook. You want to mark those, you can look at those. These are similar to some questions we're going to see in the apply. Read this carefully. It's not meant to trick you, but pay attention to what the words are telling you. Trent missed 9 out of 60 questions. What percent? Okay, so I need an answer in a percent form. But what percent of the questions did he get correct? Did you notice that? It told us how many he missed. He missed 9 out of 60. But the question asked, what percent did he get right? Okay, so let's think about this for a second. If he missed 9 out of 60, then how many questions did he get right? So 60 minus 9 is going to be 51. So he got 51 out of 60 questions correct. Okay, that's the fraction, the ratio of how many he got correct out of the total number of questions. So if I take this fraction, I'm going to divide 51 divided by 60. Okay, just typing that fraction in, 51 divided by 60. And I get the decimal 0.85. I can turn that decimal into a percent by multiplying by 100, which shifts that decimal 2 spots to the right, and I get 85%. Guys, if you just take your calculator and multiply that times 100, it will shift it for you. That's how you get 85%. It asks for a percent answer, so make sure to give that percent answer. Okay, one more word problem.
I have a question on that, if you don't mind.
I'll go right back to that. Sure thing.
So for numbers 10, 13, and 14 on 5, I'm assuming are those because that's what stumped me for whatever reason. Okay. I was doing it difference divided by original times 100. Is that totally wrong?
Let me turn that. You said which one? 10?
10, yeah. So like I did 83 out of 90. So I did the difference minus the original. No, difference divided by original times 100. And I'm not sure where I got that from. I feel like I got it in the...
You're basically doing the same thing we just did.
Yeah, but that way's totally more easier. So I'm gonna stick with that.
Okay. All right.
Thank you.
Yes. I'm trying to see. Actually, on
because I put question marks beside them because, like you said, I was looking into it way too more than I do.
Trying to look. 12 looks like. Let me see if I have one like that. This may be like 12. The way that way. Okay. Let's take a look at this one right here. So 5 is what percent? I don't know. That's the question. Of 2,000. Okay. So I could rewrite that actually as 2,000 W equals 5. Some students just like the variable on the left-hand side. That's not a big deal. And I know students are sometimes trained divide the bigger number by the smaller number, but that is not necessarily how we do problems. Divide by that number in front of the variable. So I would take my calculator then and take 5. Sorry, Blair. 5 divided by 2,000. Okay, I'm going to get that decimal, and then times 100, like we said. So that's 0.25%. Okay. Let me finish this last one, and then if we need to go back over 11, if that doesn't clear up your question, we can do that.
Just the way you made, I'm not sure where I got that from. This is where I'm going to go back and look at the presentation. But
I really think number 10 is like identical to that number 21 we just looked at there.
Right.
Let's do this last one here. It says, Joshua purchased a camcorder for $980 and paid a sales tax of 6.25% of the cost. So what is that total cost of the camcorder? Here, this is real life. Every day you buy stuff, you're going to pay tax. This is how it works. Of means multiply. We are multiplying tax times that cost right there. So 6.25% times $980. If you have a percent button feature on your calculator, or maybe you're using your cell phone, and that may work out fine for you, just note, percent means divided by 100, so we shift that decimal over 2 spaces, so 0.0625 times 980. What this is going to give me, though, is the tax only, okay? 0.0625 times 980. So that's $61.25. Okay, that's tax only. But this question is asking for a total cost. So this is actually like a 2-part problem. I have to find tax, and then I'm going to take that tax and add it back to the original price so that I can get that total. So adding that back to 980 is going to give me a total of $1,041.25. Okay, So you may have some questions like that where you have to find one answer and use that answer to get another answer in the problem. Just be careful with tax. We multiply that times the cost. So I had to shift my decimal over 2 spaces, multiply with tax. Okay. All right, I'm going to end our recording right now, and then we can continue to go over more questions if you have them at this time.